An octopus grabs one crab near the reef. That should be the whole story. One hunt, one meal, done. But a few minutes later, without moving from that same spot, the octopus catches a second crab. Then a third. It did not chase any of them. It did not even move. Somehow, the very first catch pulled the next ones in all by itself. That sounds strange. How can catching one animal help you catch more, without any extra work at all? Shouldn't the noise and the struggle of that first catch scare other animals away, not bring them closer? Most people would guess the extra crabs just happened to wander by at the same time, by pure luck. Maybe the octopus simply got lucky 3 times in a row, and the first catch had nothing to do with the ones that came after. But that guess is wrong. This happens far too often to be just luck. Something about that first catch is actually pulling the other crabs in. To understand why, you first need to understand what happens the moment an animal, like a crab, gets hurt underwater. Here is the real answer. When a crab gets grabbed and hurt, its body releases tiny chemical signals into the water. You cannot see these signals, you cannot smell them yourself, but other crabs nearby can sense them clearly, almost like a smell carried on the current. These signals do not always mean danger to other crabs. Sometimes they seem to mean something closer to food. A hurt or dying animal in the water often means a meal is close by, since that same chemical shows up when food is being torn apart nearby. Crabs, like many ocean animals, do most of their sensing through the water itself, not through their eyes. Tiny hairs on their legs and feelers can pick up even a very small amount of certain chemicals, and their brains have learned over a very long time to connect those chemicals to certain outcomes. One kind of signal might mean danger, so the crab moves away. Another kind might mean food, so the crab moves closer. The trouble is, both of these very different situations can end up looking almost exactly the same in the water, since a struggling, injured animal creates signals that fit both meanings at once. So instead of swimming away from danger, some nearby crabs actually swim toward it, hoping to find scraps of food near the disturbance. They are not walking into a trap on purpose, they are simply following a normal signal that usually leads to food. Most of the time, that signal is telling the truth. This time, it is leading them straight to a hungry, waiting octopus instead. This is the real trick behind the whole hunt. The octopus does not need to actively call other crabs over. It just needs to catch the first one and let the ocean do the rest of the work. The moment that first crab gets hurt, a chemical signal spreads outward through the water on its own, and it keeps spreading even while the octopus is calmly eating. Some nearby crabs picking up that signal will swim closer to check it out, walking straight toward the same spot where the first catch just happened. Because of this, a smart octopus does not need to rush around the reef searching for its next meal. It can simply stay still after that first catch, tucked partly out of sight, and wait. The chemical signal becomes almost like an invisible fishing line, pulling more food toward the same exact spot without the octopus lifting a single arm to make it happen. Staying still also helps in another way. Many crabs are cautious, and a fast-moving predator swimming around the reef is much easier to notice and avoid. But a predator that is not moving at all, especially one already blending in against rocks or coral, is much easier to miss completely. So the octopus gets 2 benefits from waiting in one place instead of one. It saves energy, and it also stays harder to spot right at the exact moment when a curious, hungry crab is creeping closer to check out the disturbance. This idea, using the leftover signs of one meal to help catch the next one, is not limited to octopuses either. Certain fish that hide near reef cracks and crevices seem to behave the same way, staying unusually still and alert right after a successful catch, almost as if they are expecting a second visitor to arrive soon. Some sharks are known to gather quickly around any blood or disturbance in the water drawn in by the exact same kind of chemical signal, even though they had nothing to do with the first attack at all. In the case of sharks, this pattern can grow even bigger. One shark finding food can quickly turn into many sharks arriving at once, all following the very same chemical trail through the water. None of them planned this together. None of them called each other over on purpose. They are simply all reading the same invisible signal, each one arriving on its own, drawn toward a spot that already smells like food to them, whether or not any food is actually left there for them by the time they arrive. There is a clever kind of patience hidden inside this whole strategy. Chasing prey costs a lot of energy. Swimming fast, changing direction, wrestling with a struggling animal, all of that uses up energy the predator has to replace later by eating even more. But waiting quietly in one spot costs almost nothing. If a predator can let signals in the water pull prey toward it instead of chasing prey down itself, that predator saves a huge amount of effort for the very same amount of food. Zooming out, this shows something important about how connected ocean life really is, even between animals that never directly meet each other. A crab does not warn other crabs on purpose when it gets hurt. It has no way to control that chemical signal at all. But other crabs are always listening anyway, and a clever predator has learned to listen right along with them, using signals meant for one animal to quietly call in the next. None of this required the octopus to plan anything clever in a human sense. It did not need to trick anyone on purpose or set up a trap the way a person might. It simply learned over time that staying still after a catch tends to bring more food, and that lesson was enough. Nature does not always need a clear plan to look this clever from the outside. Sometimes a simple habit, repeated again and again, ends up looking exactly like a trap, even if no one ever meant to build one. So somewhere near a quiet coral reef, an octopus rests in the same spot where it just finished its first meal. It does not chase, it does not search. It simply waits, tucked low against the rocks, as a second crab begins moving toward it, drawn in by a signal it cannot see, cannot question, and has no way of knowing came from a trap.